Hi guys, this is continuation of the last class. Last class we learned what is differentiation and I gave you 4 formulae. And now in this class we are going to learn how to apply the formulae. Instead of going to the first principles and doing it from the first principles, we are going to straight away use the formula. Like if I ask you what is the differentiation of x cube, then what does it mean was done in the last class. What does it mean? It means that if you vary x, how does x cube vary? That rate of variation of x cube with respect to x. That was the meaning of differentiation, right? Like if I say, what is the differentiation of sine x with respect to x? What does it mean? It means if you are varying x, then how much does sine x value vary? Then the ratio of that. How much sine x varied divided by how much x varied, that ratio, that gradient, that rate of varying is called differentiation. Now, how did we get a cos x is not your concern right now. It is through the first principles. When you are done with trigonometry, you will come to know how we got that mathematical value. But the thing is, we are not doubting these expressions, and this is what we derived that day. We did not derive these, but you can always derive those once you have been equipped with so much of maths in you. So what was differentiation? How does this function vary when x varies? That rate was your differentiation. Now, instead of using first principles, now we are going to use some techniques to differentiate. So I'm just picking from the last class. What I gave was d sine x square or x cube, I gave something like that, by dx. Now what's the answer? You gave us various answers like cos x square, which I said is wrong. Then something else. The thing is, you can't say that d sine x square by dx looks like this formula, and hence sine x, d of sine x by dx was cos x. Therefore, d of sine x square by dx would be a cos x square. That is wrong. That is wrong, because if I go back to the basic definition, that is how sine x varies when x varies, and that rate is cos x, then it is not necessary that when I vary x a bit, sine x square will vary with the rate of cos x square. There is no guarantee of that. So you can't simply put that. In simple terms, if I tell you x square is a separate thing, d of sine t divided by dx, meaning to say, how does sine t vary with respect to x? Answer shouldn't be cos t, because this variation of x is not variation of t. Your dx was not equal to dt. Had dx been equal to dt, this answer was absolutely right. Meaning to say that when you can't just be looking at the numerator, you have to see that the differentiation has been asked with respect to what? With respect to what? And that's our first technique what we'll be doing today. What we are going to do today is apply some techniques. We are hoping to cover chain rule, then product rule, and then quotient rule. So these are going to give us some techniques so that we don't have to go back to the first principle, which is quite cumbersome, and do that way. We can always use first principle, but that it would take too much of time, and it's not that worth. We have already derived through first principles some formulae, and through those formula and some techniques, we can always get the answers which we can. So it's not like we are going to cover all kinds of functions. We'll be able to differentiate every kind of thing. Our agenda, as was told earlier, is to be able to differentiate functions which are going to come in physics and chemistry for now. So we should be good enough to be able to differentiate those things and later integrate those things. So that's our agenda. So these differentiation and the techniques what we are going to do would be good enough for those functions. So the first technique what we are going to do is called chain rule, and you'll soon see why the name is called chain rule. Now suppose I take a function x cube plus x square, say whole power 3, and I have to differentiate with respect to x. How would you do it with the knowledge till now? One is, you can always expand this. What do you get? x cube power 3, or shall I take x square common outside, and x square and power 3, that is your x power 6, and what is in here is x plus 1 whole cube. That's your function. I'm just rewriting the function. Yeah, good for me. I'll come back to this question and we'll apply product rule also later on once we have done. So just, I hope I remember to apply product rule on this. I'll note it down somewhere. Okay. So what is this? This is d of x cube into x power 6. So that's x power 9. Then you have a 3x square and a 1. So x square and x power 6 is x power 8. And then you have a 3 and a x and a 1 square. So x into x power 6 is x power 7. And then you have a 1 cube and x power 6. So that's a x power 6. So this is what was asked to be differentiated. So what is the differentiation? Last class we discussed that d of this, d of this, d of this. So all of them can be separated out. And the reason is, if you go to the basics of maths or first principle, you can see that yes, you can separate out when you are taking those limits. So you can separate it out. And what will this give? That will give a 9x power 8 according to that formula. The power comes in front and the power of x reduces by 1. So that gives you 9x power 8. This becomes 8x power 7 and a 3 is already there. So 8 into 3 is 24x power 7. And similarly this will be 21x power 6 and that will be 6x power 5. So I hope you got that. And mind you, you have differentiated. That's the rate of change of this thing with respect to x. So don't put a dx separately now. This is your answer. This is your answer. You can take x power 5 common and rewrite the answer in a certain way. You can take 3 also common in this. So what is this? We have a 3 common. We have a x power 5 common. So what is the first term? It is 3 times x cube. What is the next term? It is 8 times x square. What is the next term? It is 7 times x. And the last term is 2 times 1. It's just 2. Right? So that's your answer. That's one way of doing it. But had the power been 30 instead of 3, if it was 30, then we won't be writing an expansion. That will be too long for us. We'll apply a rule. We'll apply a technique. But for sure, is the answer 3x cube plus x square whole square, meaning to say if it was t cube differentiation is 3t square. But t cube differentiation with respect to t is that. So is this the answer? Is this thing same as that thing? It is not. You can expand and you can check out. It isn't. So is it the same? Not at all. It is not the same. You can check out. And this is the wrong answer. So what will be the right answer? How to do it? So if it is a complicated term, and we want to imagine that term as, right now for you I'll be writing it as, say, a different letter. Later on, I would avoid writing a different letter. Imagine that was t. So it's a t cube with respect to, differentiation with respect to x is asked. Now what do you wish? What had they asked? If they had asked dt cube by dt, if they have asked the differentiation of t cube with respect to t, I have a ready-made formula. I would simply jump onto the formula and give the answer. It is 3t square. So I wish it was a t, but it's an x. So again I'll repeat this. I wish the differentiation was with respect to t instead of x. That's my wish. I would have wished that this thing cube was differentiated with that thing. Unfortunately, it is not. So the chain rule is, if you wished that it was with t and then you say that you can do it, then grant yourself that wish. You change the question. you change the question and say, I don't know this, sir, but I know this. I don't know how to differentiate a t cube with respect to x, but I know how to differentiate a t cube with respect to t. And you change the question and you write it as dt cube by dt. But can you change a question? So don't kid yourself, you can't change a question. You have to make it mathematically same. So you have introduced a dt from your own side. So it is like rate of change of t cube with respect to t. But then what is the rate of change of t with respect to x? It fits in beautifully. It fits in beautifully and you don't have to worry whether it works or not. It does work. We can go to the basics and check it works. But if you look at the math right now clearly, a dt cancels with a dt and the original question remains dt cube by dx. So you wish that it was differentiated with something what you know, then grant yourself that wish, differentiate it, but don't change the question. If you have introduced a dt, put the dt and put the original thing back what it was. Now you figure out whether you can do this or not. If you can't do this and you wish it was differentiated with something else, you put that and then put that thing back over here and again a dx. So it keeps on growing if you have a long list of wish, and hence it is called a chain rule. So let me just do this question, demonstrate this and a few more questions before I start giving you questions to do. So what is there? I have called this as t. Later on I'll avoid putting an extra variable over here because we'll want to do these questions in our head ultimately. So what's your t over here? T is x cube plus x square. I've called that as t. Now I can do a dt cube by dt, which is a 3t square. And when I'm finally reporting the answer, 3t square instead of t, I can put back my x cube plus x square. But then what is dt by dx? What is dt by dx is what I have to do. Get the point? So can I do that? Yes, I can do that also. This is a pretty easy one. So dt by dx will be how much? I'll write it over here separately for now. Mind you, later we'll not be writing it separately like this. Dt by dx is what? Dt by dx is 3x square according to that formula. It's a cube of something. Do I have a formula? I have a formula of a power of something, a sine of something, a cos of something, and a log of something, natural log of something. These four I've got. If a question is given beyond the scope of these four, then you don't know it, then you don't know it. Then don't worry about it. Okay, I'll just add one more. I'll just add one more to the list. D of e power x with respect to x is e power x. That's crazy and wonderful. Slope of a e power x curve, and you should be knowing e power x curve by now because of this COVID thing, exponential growth and all. Wherever you go on the net or TV, they are showing that graph. So that e power x graph, if you draw the slope of it, the slope is again the graph itself. That's so beautiful, and it is not for any number power x. It's a special number. E is a special number. How does that come? That's again a story. How does the graph look like? E power 0. If you put x as 0, e power 0 is how much? 1. If I put x as 2, e power 2 is how much? E is around 2.7. So you'll square that and it will be a big number. It doesn't go down, it goes up. And if I go on the negative side, e power say minus 1. E power minus 1 is 1 by e, it's a positive number. E power minus 2 is 1 by e square, a positive number, but a fraction. So it goes down. So it goes down and the graph looks something like this, right? And the crazy thing is, at say 1, you want to find the slope. The value of the slope will, this inclination, that dy by dx over here will be the value of e power x, e power 1 itself. Yeah. So at x is equal to 0, the value is 1, and if I check out the slope, The slope I should have drawn at 45 degrees. Unfortunately, I haven't. It goes like this up at 45. The slope itself over here would be 1. And the slope behind over here, all these slopes would be some positive number. All these slopes are positive. It's not 0. It's some positive number, but less than 1. That's a fraction. And the value would be the value of the y itself, e power x itself. That's a crazy one. But again, coming back to the question at hand. What is the question at hand? I had to differentiate this. I could always cube it. I could do that. I did that. I got the answer. This is absolutely right. Absolutely right. But then I was thinking it's a cube of something. I'll call that something in my head as t. It was a cube of something, and I wish it was differentiated with that thing. Unfortunately, it is not. So I'm just revamping the question, and I say a cube of something is differentiated with that thing. Then I know the answer, but it doesn't matter you know the answer or not. You can't change the question. So when you have introduced a dt, you put a dt back and differentiate it if you can. So the question becomes, so the answer becomes dt cube by dt. That I know. How much is that? How much is that? That would be 3t square. 3t square. Right? That is this part. That is this part. And then we have a dt by dx. So we were writing over here. Oh, midway I went somewhere else. I'm so sorry. dt by dx. How much is that? It's a cube of x. It's a cube of something. Applying that formula, it is 3x square plus a square of x. It is 2x. 2 comes in front, and the power of x goes down by 1. So this formula is valid for any constant n. Any constant. Negative also. Okay. So dt by dx would be how much? Dt by... I'm sorry, the thing got disconnected. So what we were doing is writing the t in form of x. So t was x cube plus x square, and we have a t square, so square of that, and then we have a 3x square 2x. I'm claiming that this answer and that answer is ditto same. Do you want me to work it out, or is it okay? Do you believe it? Do you believe, or we should work it out? What do you think? So just for this time, it has to be same, but just for this time, just to give you that effect, we'll just work it out. So x square I can take common, x square and then square of that. So x power 4. X power 4 is outside. 3 times that. 3 times x power 4. From here x I can take common. So x power 5. Right? So what is left in this, what is left out of this is x plus 1. X plus 1 whole square. X plus 1 whole square is x square plus 2x plus 1. And this is, we are taking x out, so it is 3x plus 2. Now if I open up this, I hope to get that. So I'll just match it straight away. We have a 3x power 5 outside. We have a 3x power 5 outside. X square into 3x is giving you 3x cube. All right. Then we have an x square into 2, which gives you 2x square. But we have more x squares over here. 2x into 3x, which gives you 6x square. So 6x square plus 2x square, we have a 8x square. All right. That's all right. And then how many x's? So a 2x into 2 will give you a 4x, and a 3x into 1 is going to give you 3x. So 4x plus 3x, we have a 7x. So yes, we have a 7x, and 1 into 2, that's the only constant term, is 2. So this one is this one. This is all more bracketed up. It is all in factor form. So looks much more better also. So this is the way we'll follow instead of opening up. Is it clear? Is it clear? Are the steps clear? The steps are, they are asking me to differentiate x cube plus x square power 3. I'll read it as it's a cube of something. I don't even read what that thing is. I can call it something in my head. It's a cube of something. I wish it was differentiated with that thing. I wish it was differentiated with that thing so that I can apply the given formula. This guy should match this guy. This thing should match this. X matches, then only I get that answer. This guy matches this guy, then only I get that answer. It has to match. Otherwise, I can't just impose my answer without that matching, because it has great deal of math behind it. So I wish it was. I can't change the question. I can't change the question if I had introduced a dx cube plus x square. In the same breath, I will just remove it. I'll put it, I'll remove it, so that I'm not damaging the question. And what was there, I'll put it back. Was the d missing all the time? Oh my god. So what was there, I'll put it back. Is it clear? Is it clear? So this question is equal to this question. This one is a doable one. It's a cube of something. I'm not reading that something. That something may look like all hazy to you. That doesn't matter. That pink garbage cube with respect to that pink garbage is 3 garbage square. It is 3, whatever that thing was, which was a x cube plus x square. I'm not even reading it. Square. That's your first part. And this comes according to that formula. And this one, as we have said earlier, if it is a plus or a minus, we can separate it out. If it is a multiplication, you can't. So if it is a plus or minus, you can separate it out. So this is a 3x square for the first guy, and this is a 2x for the other one. This you read like dx cube plus dx square. The differentiation has been distributed on the 2 with respect to dx. So you can have dx and dx over here, and this is what we do. Is this clear? That's the answer, and then you can represent in more pretty form by taking common and stuff like that. Is that clear? Is that clear? So I'll come back to the question which guys, some of you answered in fact last class, but others made a mistake. Yeah, what was it? X square or x cube? So I'll just put a x cube over here. X cube with respect to dx. Does it match any of the formula? It doesn't. Is it somewhat some of the formula? Yes, it is. But does it match any of the formula? It doesn't. So how do you read? What's the first step? How do you read? In fact, I'll give you half a minute to do it. Just do it. So pause your video and then come back and see what I'm doing. How do I go about it? What is the function? Let me read the function. It is, first of all, is it a cube of something? No, it is not. It's not a cube of something. I hope you know how it works. If I have to say sin x whole cube, that's quite different from there. Now this is a cube of something, right? Right? So what it is, what is this guy? It is a sine of something. That is what I'm saying in my head. A sine of something. D sine of something. I'm not even reading what thing that is. Sine of something. Now sine of something with respect to that thing has an answer in the formula. So I wish the differentiation was with respect to that thing. What is that thing? X cube. Right? Right? But is this question the same as this question? Obviously not. This part is, but this is not. I have just put in my own wish over here. So when I put in my own wish over there, I have to remove that also, because I can't change the question for sure and make the question mathematically same as the earlier one. Right? Right? Now can I differentiate this? You can read x cube as t in your head. X cube as t. So what is this question? D sin t with respect to t. D sin t dt. So what's the answer? D sin t dt will be cos t. So the answer over here is quite simple. D I'll not repeat. I'll not write d sine t and all. So d sine x cube with respect to dx cube is cos x cube. I hope you got that. So that's the first part. That's the first part. And the next part, say this white part. What is that? D of x cube by dx is, by now I hope we have become very cool with this. So it is x 3x square. So that's your answer. 3x square into cos x cube is your answer. Cos x cube. That 3x square is outside the cos. I hope you understand. So cos x cube 3x square is the right answer. So as some people told last time that it would be cos x cube, not at all. This is quite different from that, right? There's a 3x square also. So that's the answer. I hope you have understood. You may pause the video, you may rewind and check it out what is happening. But then I'm not going to give you very many examples, and I'll start asking you to do some questions. Okay? One small thing, one small very little concept I can introduce over here. And before giving you that question, let me see what you do about this. Let me straight away give the question. D of sine 2x with respect to x. With respect to x. Are the variables matching? No, it is not. Slightly off. Slightly off. It's off by a constant. It's a linear kind of off. It is not like it is square and all. It is slightly off. So what do you do about it? Yes, guys? What do you do about it? So as I told you that this can be written as sine 2x. I wish it was differentiated with respect to 2x. And then I put this from my side, then put it down. And what is the answer over here? Answer is sine 2x with respect to 2x will be cos 2x according to the formula. Now what about this one? What about this one? D of 2x with respect to dx, what will that be? So 2 as a constant, in the last class we have told it can go out. We have given you a sheet to practice those things. So this becomes 2 and dx by dx. Dx by dx is 1 obviously. So that is nothing. So it becomes 1. That thing becomes 1 and a 2 outside. So the answer is 2 times cos 2x. Now what I am trying to tell you over here is that we use the fact that a constant can go out of the d. Meaning to say 2 times dx is as good as d of 2x. This can jump out or jump in and it's not going to matter. It is like saying change in x. If you double the change, it is same as change in 2x. It's same. It's a linear factor of 2 over there. So ultimately I use the fact that a constant can go out. Then why to do the chain? Why to do the chain? And straight over here I may think that let me make it as 2x over here. I mean it's almost the same thing, but I'm not doing the chain exactly. And I'm saying that I can put a 2 on top and a 2 on bottom. Doesn't change the question. And instead of this taking the 2 out, what I'm doing over here is taking the 2 in. If I take the 2 in, what does the question look like? 2 d of sine 2x by d of 2x. You put a 2 on top, 2 on bottom, and instead of dx, you made a d of 2x over here. You made a d of 2x. So this part will give you this answer, and that 2 outside is that 2. Is that clear? So sometimes you can avoid writing the chain if it is a linear thing like this. Got it? Got it? Doesn't matter much. You do this, you do that. It's almost the same thing. Doesn't matter much. So do a question for me now. So note down these two questions. do them and do them in quick time. So pause the video and don't watch the answer till you have done, and then match your answer later on. So how do you do it? What is the way you do it? You'll read the function, forget about the denominator, you'll read the function in English, in words in your head. You'll read the function. It is a sine of something. I hope you know that sine cos x means the angle is x, cos of x has been done, and cos of x gives you something, and that becomes the angle for sine. So sine bracket is somewhere from here to there. So what is this? It's a sine of something. It's a sine of that green thing, right? So which of the functions will help you? Do you have a sine of something over here? Yes, we have a sine of something over here. There's a sine of something we have. So we wish it was differentiated with the same thing. So this becomes d sine of that thing, and I'm not very interested in writing that, to emphasize the fact that I don't care what is in there, but I'll have to care very soon. D of the same thing, But then I can't change the question. What is here has to be here, and I'm differentiating with respect to that, so I'll do away with that. So I'll write a d of this thing again. So what was it, by the way? It was cos x, right? So I have to write d of cos x and differentiate it with respect to the original one. The original is dx. So I have not changed the question. This is there, that is there, and this mathematically goes away. What it means more in depth is the rate of change of sine x with respect to cos x, the rate of change of sine of cos x with respect to cos x times the rate of change of cos x with respect to x will be the rate of change of sine of cos x with respect to x. Think a bit on this yourself. So that thinking part is deep, doing part is quite cheap, quite easy. There's hardly anything in this. So sine of something with respect to that thing, what's the result for that? What's the answer for that? What will it give? Sine of something with respect to that thing gives you cos of that thing. What was the thing? That thing was cos x. Cos of cos x. And what about d of cos x with respect to x? That's a minus sine x. So you get a minus sine x. So your answer is this into this. So writing it in a more pretty way, it is minus sine x times cos of cos x. That's your answer. If you wish, you can put a bracket, minus sine x into cos of cos x. I hope you got that. Now what about this one? So those who did not get that right, again pause the video, because you might have done a mistake in here, and redo it if you feel, or check, and then play the video. So just go ahead and solve this one. Again, I'll read it as, is it a cos of something? Is this function a cos of something? No, it is not. Is it a sine of something? No, it is not. It's a log of something. It is for sure a log of something. So how to start with this? D log or whatever thing with respect to that thing. What is that thing? That thing is sine cos x square plus 1 whole cube. But actual differentiation was with respect to x, not with this. So I introduced this, so I'll cancel it out. Now with respect to x, with respect to dx makes my question same, but then I could solve this first part, log of something with respect to the same thing, with respect to the same thing, it's the same log of something with respect to the same thing. You can call it as pink thing, log of pink thing with respect to the pink thing. I can solve this, and that is 1 by that pink thing. Log of x with respect to x is 1 by x. But then this again is a problem. But had this been the original problem, what you would have done? You would have read this function again. What is it? It's a sine of something. What is it? It is a sine of something. So how do you do that? You wish it was not being asked with respect to x. You wish it was asked with respect to whatever it is, because we have a sine of something formula available. So instead of dx, you wish it was d of cos x square plus 1 whole cube. So how do I read it? Sine of a green thing with respect to that green thing. Sine of a green thing with respect to that green thing. The answer is cos of that green thing times, now this is again an introduction from your side, so you have to do away with this, d cos x square plus 1 whole cube with respect to say dx. Is this question same as that question? Mathematically it is, because this part is this part, this pink part is that pink part, this green part is that green part, this cancels with this cancels with that, and this is the original thing, that's the original thing, they are still there. But can I differentiate this? Again it is cos of something with respect to x, so I would rather have it cos of something with respect to that thing, which is x square plus 1 whole cube. So I have introduced something from my side, I'll do away with it, x square plus 1 whole cube with respect to x. I think I'm going to exhaust the board limit. Again, is the question still same? This cancels with that, this cancels with that, this cancels with that, and the question is same. This and that was originally, it is same, but we are just wishing that it was with respect to this, with respect to this, with respect to this, so that we can do it using those formulae. Now what is it? It is cube of something, cube of something. Either you expand it, apply the whole cube formula, or do a chain over here also. It's a cube of something, and you wish it was with respect to that thing done. You wish it was differentiated with respect to x square plus 1. You put your wish, you remove it to be consistent with math, and put a dx. I hope it has come in the board. I think it has. So that's your chain. Hence chain rule. It may ultimately create a long chain also. Get the point? Get the point? Now what is the answer for each and every part? That blue part, log of something with respect to that thing is 1 by that thing. So what is it? 1 by, what was the thing? I almost scratched it out. Sine cos x square plus 1 whole cube times sine of something with respect to that thing. Sine of something with respect to that thing. It may look all very complicated and all, but it is very simple. Sine t with respect to t. Sine t dt. What is the differentiation of this? This looks like, in my mind, this looks like sine t, d of sine t by dt. Answer is cos t. Cos t. So answer is cos, and what's that t? That t itself is a cos x square plus 1 whole cube. So the next bit is giving me this answer. The first bit gave me this answer. What about this thing? Cos of something with respect to that thing is a minus sign of that thing. So minus sine x square plus 1 whole cube. This is giving me that answer. What is this? It's something cube. So the formula is similar to the first one, something cube with respect to that thing. So it will be 3 times 3 times that thing square. That is this one and the last one. These are two separate things. You can separate it out. It becomes a d of x square by dx plus d of 1 by dx. Now what is d of x square by dx? That is a 2x. And what is a d of 1 by dx? D of 1 by dx. You don't see a x over here, but we have none of that formula. So one thing is, by basics, what is the change in the number 1 when you change x by something? What is the change in number 1 when you change x by something? There is no change in number 1, it's a constant. So differentiation of a constant is 0. That is the logic you should be thinking. But then, if you want to be too much into formulae, you can write that 1 as d of x power 0 by dx, that d of 1, that 1 can be written as x power 0, and you can use the formula 0 comes in front, so 0 comes in front and x power minus 1, but 0 times anything is 0, so that becomes 0. That is through formula. But if formula gave me something else, I would have never used it, because I know change in a constant is nothing, is 0. Change in constant with respect to x is 0. If I have to draw a graph of y is equal to 1, that y is 1 over here, dy by dx, that y is 1. Y is 1 is this straight line 1. With respect to x, it is not changing. What is the slope of the graph? 0 is the slope of the graph. So yes people, this is the answer, that d, if that is your y, then dy by dx is this big fat thing. I hope everybody got it. Now I'll give you another one where many a times you make a mistake. Many a times. So becomes a special question, but it is as easy as these ones. So do it properly. And I'll not put a very long chain to it, so that we emphasize on the part what most of the kids do wrong. D of sine cube x, say square. D of sine cube x square. Do this, pause the video. So I really hope all of you got this. I really hope you broke it into the right chain. Now how do I read this? How do I read this? Is it a sine of something? Is it a sine of something? Is it a sine x square? No, it is not. What is the first thing it is? Like when I read this, was it a cos of something? No, it was a sine of something. Cos of something came later. Was it a cos? Was this expression of cos of something? No. The first envelope was a log of something. So what is this? It is a cube of something. It's a cube of something. Your sine x square is like a t in your head. It's a t cube, as simple as t cube. So d, shall I write a t cube or shall I write sine x square? It's a cube of something. I hope you know in trigonometry that whole cube is denoted like this. So it's a cube of something, and I wish it was differentiated with respect to that thing. So in fact the first thing is the first formula. It's a power n of something. It's a power 3 of something. And then the chain follows, and that's pretty simple. D sine x square. You wish it was differentiated with x square. Then d of x square by dx. So ultimately your answer is 3. It was a t cube, so it is a 3t square. What's that t? Sine x square is that t, it's the square of that. I'll rather write a square over here. You can write a whole square, but that's the way we write. Into sine of something with respect to that is cos of that thing, and then 2x. So So that's your answer, and I really hope you got that answer. So this is your chain rule. You go through these examples, you'll be able to do almost all of them based on chain rule. So it equips us with a certain technique with which earlier we were stuck in solving problems like this, even though we knew the formulae which were nearby those things, but not exactly those things. We were stuck. Now we know that we can have a chain and we can do it. But what if somebody gives a very simple one, like say sin x into x, x into sin x, x into sin x. Now x plus sin x, a d of that, x plus sin x can be done, a differentiation of that can be done by splitting up, by saying it's a dx by dx plus a sin x by dx, d of sin x by dx. But if it is a product, it is not. You can go back to the first principles and check out that it is not. It is not. So next we'll be doing how to do these.